Hi, my name is Ryan Levinson. I'm a graduate student working at Portland State University. The title of my presentation is Paleoseismic Evaluation of Slip Rate and Most Recent Earthquake Timing Along the Mount Hood Fault Zone, Oregon. Here is an overview map of the Mount Hood Fault Zone. North of the summit, we have the Gate Creek Fault and the Blue Ridge Fault. South of the summit are the Multiple Mountain and the Twin Lake Faults. I focus on three locations outlined by the three black boxes shown on this map. The primary objective of this project is to characterize the slip rate and the timing of the most recent earthquake on the Mount Hood Fault Zone through detailed quaternary mapping and geochronological techniques. Slip rate and most recent earthquake data from several sites along the fault length will provide new insights into how strain is partitioned between structures within the Cascade volcanic arc and the Basin and Range. This work is ongoing and I plan to do additional fieldwork this summer. Here is a geologic map that shows a glacial moraine cut by the Blue Ridge Fault. Moraine crests are mapped with gray lines and sample locations are shown by the black dots. I sampled the surface of well-exposed boulders for cosmogenic helium-3 exposure dating. I am preparing these samples to be run at Berkeley Geochronology Center. The vertical separation of the moraine crest is 2.67 meters. I use a MATLAB script that fits regressions through surfaces and calculates vertical separation, fault dip, fault position, etc. for profiles drawn perpendicular to the fault. Now we're going to take a look at the paleoseismic coring transects I performed along the Twin Lakes Fault. On the left, I show a geologic map of the Twin Lakes Fault near the White River where there is a scarp block drainage 10 kilometers south of the summit of Mount Hood. I have mapped glacial till as QGET, an infilling silty deposit as HTS, and a marsh as HM. The inset map shows the location of my coring transect where I used gouge cores to map the stratigraphy across the fault and collect C14 samples from offset surfaces. This cross-section shows a ground surface, HBS, that was faulted and buried by a silty deposit, HTS. Preliminary C14 age dates suggest that the buried ground surface is 3,500 years old and the overlying silty deposit is 1,000 years old. MRE timing at this site occurred between 3,500 years and 1,000 years ago. The vertical separation of the ground surface here is 1.35 meters. I calculate a vertical slip rate of 0.3 millimeters a year at this site. Now we are going to move 10 kilometers south along the Twin Lakes Fault and focus on Frog Lake. On the left, I show a geologic map where glacial gravels are shown as QG, quaternary alluvium as QAL, and focus on the lake deposits mapped as HLK. The inset map shows the location of my coring transect where I used gouge and auger cores to map the stratigraphy. The cross-section shows offset lake sediments and a colluvial wedge. Preliminary C14 ages of organic material collected from within the lake sediments suggest that the age of the lake deposits are 8,000 years old. Most recent earthquake timing at this site is not well constrained, but I estimate 1 to 2 events occurred within the last 8,000 years. The vertical separation of the ground surface here is 2.07 meters. I calculate a vertical slip rate of 0.2 millimeters per year at this site. So here are preliminary conclusions. This is the first quantitative evaluation of fault scarp heights and ages of displacements along the fault zone. I suggest that faults north and south of the summit are an active seismic source. Here's a table that summarizes the measurements and calculations I've made along the fault zone. Finally, I calculated the average displacement of 1.8 meters along the Twin Lakes Fault and measured the entire length of the fault zone to estimate earthquake magnitudes. Empirical scaling relationships derived from regressions between magnitude and displacement for global database of surface rupturing earthquakes show that 1.8 meter average displacements are associated with a magnitude 6.9 earthquake. Regressions between rupture length and magnitude also show that if all 55 kilometers of the Mount Hood Fault Zone ruptured together in a single earthquake, it would generate a magnitude 7.9 event. I would like to thank AEG for hosting this event, and I'd be happy to answer any questions. Thanks.